Hello, everyone. 7.3, basic counting principles here. So after this section, you should apply and use the addition principle, draw and interpret Venn diagrams, and apply and use multiplication principles. So here's some question prompts that you should be able to answer by the end of this section. Suppose you're waiting for a new vehicle to come out. It has these possible options with the available choices in parentheses. Exterior color, there's 8 possible choices. Interior colors, 3. Transmissions, 2, and engine types, 3. So how many different variations of this model are possible is a question you should be able to answer. Some of you guys already probably know the answer. 8 times 3 times 2 times 3. So that would actually be what we'd find out for the number of variations. You're going to find out that we're going to use this when we do probability. So this is an important concept for us to understand when we move into chapter 8. So a combination lock has 4 wheels, each labeled with 10 digits from 0 to 9. How many 4-digit opening combinations are possible if no digits is repeated? Some of you guys might already know the answer, right? Now, how about if I make a twist to it? If digits can be repeated, successive digits must be different. So you might be wondering, how do you solve that? Well, we'll go through that here in a little bit too. A group of 100 people who visited Grand Teton National Park, including 24 who biked, 62 who hiked, and 18 who did neither, and just drove around in their automobile. How many people in the group hiked and biked? So we'll be able to solve things like that as well. So I'll show you this real quick. So if you feel pretty confident with this. So we have basically 7.3. And let's see if we can get that in focus. And I'll make this a little bit bigger. So for 7.3, the first one, I ask you for the different models. So we'll call this example A, if you will. So example A, basically we'd have 8 times 3 times 2 times 3. That'll give us basically the number of different possible variations of that. So 8 times 3 is, well, we can do this. 3 times 2 is 6. 6 times 3 is 18. 18 times 8 should give us, what, 144? Let's make sure that's correct. So 8 times 3 times 2 times 3, 144. In B, we have the combination lock. So in the first case, right, there's 10 digits for the first one, 10 digits for the second number, 10 digits for the third number, and 10 digits for the fourth number. So basically 10 to the fourth. Oops, sorry. And then that's for basically what? Any number, and they can be repeated. And the other one says if digits, oh, sorry, that's for digits can be repeated. First says how many 4-digit opening combinations are possible if no digit is repeated. No digit repeated. So it's probably easy to understand digit repeated. So there's 10 ways to pick the first one, but then once you've used one of those up, you only have 9 more to pick from. And then you only have 8 more to pick from. And then you only have 7 more to pick from. So that's one way that we can do that. And so 10 times 9 times 8 times 7 would be the answer there. Not so much important for me to write down that part, but that way you got that. And now, how about if successive digits or numbers must differ? What that means is basically, for example, in the first one, I can pick 10 because it doesn't matter which one I pick. And the next one I can pick 9 because I can't pick the one that was right before it. And then in this one I can pick 9 as well because it just can't match that one. And then 9 as well. And then that would be our answer for that one. So we'll go through and do a couple more of these here in a little bit, but I just figured I'd give you a little teaser on that. So in this section, we'll see how set operations play an important role in counting techniques. So to see how sets play a role in counting, considering the following examples. In a certain class, there are 23 majors in psychology, 16 majors in English, and 7 students who are majoring in both psychology and English. if there are 50 students in the class, how many students are majoring in neither of these classes? So what we can do, there's two ways of doing this kind of problem. So one, we can draw a table. And right now you can't see my table, but I'm drawing it out real quick. So you can see, we could do a table if we wanted. We could have psychology and not psychology, right? Again, this means psychology, and this means not, oops, oh gosh, not psychology. And then up here, we'd have basically English and not English, okay? And so we would want to say this is the universal set, right? And so it should sum up to 50 is what we should know. So we can go that as well. So in a certain class, there are 23 majors in psychology. So we know that there are total 23 psychologies. And there's 16 majors in English. So we know that as well. And 7 students who are majoring in both psychology and English. So that would be this one, okay? And then all we need to do is basically figure out the difference between these two and sum them together. So how do we get to 50? Well, that would be 34. And how do we get to 50 here? That'd be 27, right? Right, going this way, if you add these together, it should give you 50. Add this way, it gives you 50. 23 minus 7 should give us 16. And 7 and 16, this would be 9 here. And then this should be right here, 18, right? And if you were to sum all these together in here, they should sum to 50. And you can verify that on your own if you'd like. So also, you can draw it as a Venn diagram. And that's more commonly what I've done to solve these kind of things. And so you probably can't see my Venn diagram right now, so I'm gonna move this over. So the Venn diagram, we'll have basically the English, call this the English right here, and we'll call this the psychology here. So in psychology, there are 23 majors in psychology. So the number in P is equal to 23. The number in English is 16. And the number in psychology and English is 7, which is this value right here, okay? We also know one other piece of information. We know the number in the universal set, the whole entire class, is 50. So we need to figure out the number in psychology. So in this case, 23 minus 17 gives us 16. And 16 minus 7 gives us 9. And so if we added those together, 9 and 7 and 16. So 9 and 7 and 18 plus 16 gives me 30. Oh, sorry. 32, right? Yep, 32. And that would mean that this out here is 18 for the not in English, not in psychology, or both. And that's actually the same value that we get right here. So all the numbers should match up that we have. So if you sum these together, it should give you 50. And you want to verify that checks? Let's do that real quick, right? 9 plus 7 plus the 16 plus 18 gives us 50, like it should, right? So let's go back and ask this question. How many students are majoring in neither of these subjects? Well, in this case, we see that it's neither is 18 here, and we can see it up here as well. One thing that's nice, if you look at this, this would be not in English and not in psychology. So that would be that right there would be the not majoring in either of these subjects. How many students are majoring in psychology alone? So just psychology, not English, would be 16, which also you can see with your Venn diagram over here as well. Pretty cool. Try both these out when you're doing problems to make sure you know how to do them either way. You might find one is easier than the other, and that might make it more comfortable for you to do these. Right, so if you want to follow my solutions here, you can do this as well, but this is the additional rule. So it's the union. So the number in psychology or English is equal to the number in psychology plus the number in English minus the intersection of psychology and English. So in other words, if I was to make my box bigger again for you guys to see it. If we go here, basically, well, actually, we'll just use this slide here. The number in psychology or in English is going to be equal to the number in psychology plus the number in English minus the number in psychology and English. So in English grades, we have 23 that are in psychology, 16 are in English, and we have 7 that are in both. And that'll give us the 32 that'll be in psychology or English. Now, a second problem here. This one's a little more complex. So a survey of 100 college faculty who exercise regularly found that 45 jog, 30 swim, 20 cycle, 6 jog and swim, 1 jogs and cycles, 5 swim and cycle, and 1 does all 3. So how many of the faculty members do not do any of these 3 activities, and how many just jog? So let's do a Venn diagram. I think this is the easiest way to represent this, and this would be a little neater than if I draw it out. But we'd have a circle for the joggers, circle for the swimmers, and circle for the cyclists. The reason why we want to know that 1 does all is that was one thing they were given. 1 does all, and that's that little like triangular bulge right here, if you will. And from there, then we can break up each piece of that. And so the next thing that we know is that since 6 jog and swim, right? Jog and swim, that means this part right here is 5, and this is 1. So, and then the remaining in the region represent those who jog and swim, 5 swim and cycle. So swim and cycle would be here as well. And 4 just swim and cycle. So that would be 4 here, and 1, 4 gives us 5. And we already have 1 that does all 3 activities, and there must be no faculty who just jog and cycle. So let's go back and do that one on our own. Make sure we understand how we can draw that one out. It's nice, there's a nice drawing of it, but let's fill in all the numbers, if you will. So in this case, we have 1 circle, 2 circles, and 3 circles. And right now you can't see mine, and that's all right. But I'll show you that here in a second. We'll go back to here, make this a little bit bigger. All right, so in this case, I'll call this my jog circle, my swim circle, and my cycle circle, all right? Cycling. So in this case, this little spot right here, that's 1, okay? Because that is the number that do all 3. So let's say it's swim and cycle and jog, all right? That'd be that piece right there. Now the next thing we know, if we work backwards, is 5 swim and cycle. So that, the number that swim and cycle is equal to 5, which is actually this football here, which means that this spot right here is 1, and then this is 4 right here, okay? Oh, that's really small drawing. But, so the 4 would be equal to the number that swim and cycle and do not jog. Yes. So, and maybe I won't write all this out because it might get confusing if I start writing all these out. So let's just do this. So that spot right there is 1, this is 4, that sums together is 5, and that's how we get the 5 right here. And then 1 jogs and cycles. So that means this should be 0 here, and there's a 1 here. And then 6 jog and swim. So that means this should be 5 here because we have a 1 there. 1 and 5 gives us a 6. And then 20 cycle. So that means this is 15 here because 15 plus 4 plus 1 gives us that 20. And 30 swim. So this is 5 plus 1 plus 4, which is 10. So this is 20. And then 45 jog. So we have 5 and 1. So this should be 39. And now if we sum all these together and we think of this as a Venn diagram, I'm going to draw a line right down there, then this universal set is equal to 100. And so we need to figure out everything that's not in these circles. So if we were to sum these up, so 5 plus 1 plus 4 gives us 10. That's 30. That's 45. 45 plus 39 Some of you guys already probably know that off the top of your head, right? 84, so that means this is 16 that do not swim, cycle, or jog. And I think that's exactly what we say down here, right? Since the sum of the numbers of these disjoint regions is 84, then there must be 16 faculty who do none of these activities. So feel free again to pause that and go back and look at that again. So multiplication principle, an example. So let's start with an example here. Suppose you have 4 pairs of trousers in your closet, 3 different shirts, and 2 pairs of shoes. Assuming that you must wear trousers, we hope so, right? A shirt and shoes, how many different ways can you get dressed, right? So in this case, hopefully you guys can see. Cedar, stop. All right. Sorry, my dog was making noises. So in this case, we're figuring out the number of basically clothing articles that we can wear, right? So ways that we can do this. We can pick 4 pairs of trousers. And then we can pick 3 different shirts. And we can pick shoes as well. And we can pick 2 different pairs of shoes. So in this case, we have, oh, is that wrong? So that screws up. There we go. So 4 times 3 times 2, which gives us the 24. That's the number of different ways you can get dressed. Some of you guys may be thinking, I'm not going to wear like weird outfits, but that's one way you could look at it, right? Again, you have a black or gray, rust or olive colored pants. You have 4 choices there. Shirts, you have green, marine, blue, and dark blue. And shoes, you might have basically brown or black, and you get 24 different options. Another way that we can look at things is looking at the nodes of basically a tree diagram, which is basically what this is. And what we think about it as is basically if you're looking at different paths you can take, paths being these branches off this tree diagram. So in this case, we have 4 different ways to pick our trousers, 3 different ways to pick our shirts, and 2 different ways to pick our shoes. And then each of these nodes at the end of this represents all of those 24 combinations that we could pick. So you'll see that if you try to do a tree diagram like this, it'll get really complex very quickly. How many different ways can a team consist of 28 players selected a captain and an assistant captain? So in this case, oops, move that out of the way. First is you want to figure out how you want to select the captain. Well, there's 28 different ways you can select the captain, right? You can pick any of the 28. Then the next person, the assistant captain, assuming you can't have a player be a captain and an assistant captain, which makes no sense. There are 27 different ways. So if you do 28 times 27, there are 756 ways to arrange these to have a captain and assistant captain. So here's another example. A sports writer is asked to rank 8 teams in the NBA from first to last. How many rankings are possible, right? So in this case, hopefully you guys would see that basically there's 8 ways to pick the first team, 7 ways to pick the second team, 6 ways to pick the third team, 5 ways to pick the fourth team, 4 ways to pick the fifth team, and so on, all the way down to 1. And basically this is the introduction of 8 factorial. And your calculator, to show you this, right? So on your calculator, if you have, you can go under math and PROB, you'll see a factorial button like that. So in this case, we want to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? That'll give us 40,320. Now, if we go to math, we go PROB, we put this in there. It's going to put my second answer in there. So I want to put 8 in there, and it has 8 factorial. Let's see, it gives me the same exact thing. 8 factorial just basically means this factorial, not meaning 8 with excitement, means that you're just going 8 times 7 times 6 times 5 times 4, all the way down to 1, and so on. So let's go back to our question prompts. I think these seem simple now. The one that we didn't solve, though, was a group of 100 people who visited Grand Teton National Park. So let's do that one. You guys choose whether you want to do a Venn diagram or a table and sketch it out. And then I'm going to pause the video real quick, and then I'll resume it, and we'll get back together. So bringing it back together, I'll make this a little bit bigger for you guys again. So hopefully you either decided to draw the table or the Venn diagram. So in this case, we fill in all the pieces of information that we know, and hopefully you filled it in the same way. We have 100 in the total set. We have 18 that neither biked nor hiked. And then we just need to figure out the addition for all those simple ones there. So if you do this, you have 20 that biked but did not hike. And so 20 and 18 will give us the 38 that we have here. And this will give us 4 that biked and hiked. And then over here, 4 minus 62 will give us 58. And hopefully 58 plus 16 gives us 76, and it does. Okay, now let's go over to our other example over here where we have the Venn diagram. We have 18 that did neither. So I have the number who biked, the number of hiked, and the number in the universal set. Number of biked and did not hike is 18. Whoops, you can't see that. So in this extent, that means if I add the bike and the hike together plus the 18, I should get 100. But if I add 62 plus 24, I get 86. Okay. Then if I add the 18 on, okay, so if I'm thinking biked and hiked and add those together and add the 18, I get 104, which is 4 more than 100, which means there are 4 that overlapped. And then basically I can figure it out from there. So the number who biked is 20, and the number who, so in other words, the number who biked were 20 and 4, so 24. And the number who biked but did not hike is 20, just like we have over here. And then in this case, we have 58 plus 4 gives us the 62. And that's basically how we solve that one. So pretty cool. You can do it either way, and I think hopefully you guys see the connection between those. And that's all of 7.3. Let me know if you have questions again. It can be a little tricky, so sometimes it's just setting this up is the most important piece. Try both ways again.